Hello! In this lesson, we are going to take a Microsoft ResNet base model, trained for image recognition, and extend it for semantic segmentation as before. Except this time, we will not train from scratch, but we will use the pre-trained weights from the original model to help us achieve more accurate segmentation results. We are going to do all of this, as usual, in a Jupyter Notebook hosted on Azure Notebooks. Hi again. We'll take the opportunity to play with transfer learning. As usual, we first ensure we have version 2.4 of the Cognitive Toolkit installed. Nowadays, few convolutional networks are trained from scratch with purely random initialization. Mostly, this is because of the difficulty in finding a suitably large labeled dataset. If the target dataset is very small, it is likely that training with it would lead to unacceptably large generalization error. Instead, the most common approach is to pre-train using a more generic large dataset, for example ImageNet or COCO, and then use the learned features from this set as an initial seed to continue training with the target smaller dataset. This is using the intuition that the knowledge gained within the layers of our network while learning to recognize certain objects could be useful while trying to recognize objects of a different type. In other words, the network will learn more useful and generic features in its layers when trained against a larger dataset, which you can then apply or transfer to the dataset of interest. This approach, we know, is called transfer learning. Again, we need to set up our data files for the lab in the FAST area on Azure Notebooks. This lab is mostly about training, but if you find it tedious waiting for the Azure Notebooks, you can set make model to false to use pre-baked trained models instead. As you know from our video lectures, one consideration when using transfer learning is what to do with the original weights from the base network model. We'll first explore freezing these weights and only allowing the final layers to train. Then we'll explore fine-tuning, where we allowed the original weights to update through regular backpropagation. Which of the two would you expect to take longer to train? Think about it. Freezing the initial weights or fine-tuning? Finally, remember one last time that occasionally Python processes can get orphaned. This means they are left behind from a previous run consuming resources in the Azure Notebook. If you see your CNN labs failing with memory errors, it is likely you have one or more of these orphaned processes running. If you are getting memory errors, especially during training, we suggest you select Shutdown to kill your Azure Notebooks session and go again from the top.